Um, Hello. So I'm making this video to say thank you to Triple Empire from Factorio Forum to help me tackle this problem, and also take this opportunity to showcase a kind of novel way to use the Factorio machine and mods. Alright, now let's get to it. When I am playing with the PY raw ores mod, and I found out that the processing of the ores require pretty similar steps and machines. For example, this crusher, I can see that this crusher is able to get quite a few recipes. So it occurs to me that instead of place this crusher in the processing line for one type of ore only, instead I may place all the crushers together and send all the materials which need to be crushed down the pipe, and let the crushers just process all of them and collect the output to set the next type of processing. But the problem is that if I mix all the kind of ingredients, all the kind of ores for the crushers, the crusher won't know what to do. I cannot set recipes for it. So this is where I get the crafting combinator mod and try to let the crusher to select its own recipes based on the inputs and to do this job. Okay, so this is how we do it. So first, this is the input line. To just for showcase, I am using 2 ingredients here, and these ingredients can be further processed by the crusher. And this is the crafting combinator. This one can send out the recipes as signal to the crusher. And if there are multiple recipe signals, the signals with the highest number is going to be chosen as the recipe for the machine. My setup is to get a constant combinator and set all the possible recipes for the crusher. Well, here I got only 4 because I'm not using all of them. I'm just using the recipe to crush the stone, crush the rock, and then to crush the small rock into sand. Okay, let's do this. Just these 2 ingredients. And this is one side of the input to the crafting combinator. We can connect it or the green way. And the next step is to read the ingredients from the buffer chest, from what is about to be sent into the crusher, and then use this recipe combinator to find uses and find all the possible recipes which are using the ingredients in the buffer chest. If we connect the buffer chest with the recipe combinator, and then let's output it to a poll so that we can read the signal. Oh, sorry. Yep, like this. This output goes to the crafting combinator, and then we connect that output to a poll so that we can read it. Okay. Alright, so this one is outputting the 4 recipes as signal, and this one is not outputting anything because all the input signals have the count as 1. And this one doesn't output anything because there's no inputs here. Now let's place some stuff here. So let's disable this inverter, so it doesn't go in there. What about some small rocks? Now you see this output now shows all the recipes that can be done by the small rocks. And if you look at the count, you can see that the recipe for the small rocks to send has a count of 2. So the crafting combinator is able to output the recipe into this crusher. You can see that the crusher, the recipe for the crusher has changed. Okay. Now, if we put in another ingredients to replace the rock, you can see the recipe changes again to processing of iron ore. Okay, this is the recipe part. Okay, so that was the recipe part. But we also have to get a clear switch to activate the machine, and then to stop the machine, and then activate a new cycle based on the input materials. So how do we do that? So first we need to get a sample from the input belt. So we use this inserter here and to pick up one ore from the main input, and let's set it to 1. Well, actually it doesn't matter, because if it's 2, it won't be 2 different items. As long as it's only one type of item, that will be alright. So this one is going to take 1 ore and put it here, and then we use the wire to read the contents and send it to the filter inverter here. Alright, we connect this to a pole, and later we can try to have a look what's in the signal system, and set this to read the belt, and this one we set it to set the field. Okay. Now if this inverter picks up 1 ore here, and this is going to be read and sent to the filter inverter here. And now let's imagine, say we have iron ore coming through, and this inverter is going to pick up 1 iron ore, and the machine now knows, okay, lots of iron ores are coming, and let's get ready and set this to pick up iron ores, and then when iron ores reach this tile, they're going to be picked up and sent into the machine here. Okay. But of course this is not completed yet, because if we just leave it like this, the iron ore is going to stuck here, and the filter will never change, and the machine cannot get ready for the next recipe. So naturally we want another inverter to give this sample back to the main input, and so that this one can pick up another sample if another batch of ore is coming through. Now the problem is, when do we want this inserter to give the sample away to start a new cycle? So naturally we know that we only want this one to activate when we have finished this one batch of iron ore. Yeah, so for example, one batch of iron ore is coming, and okay, this machine has picked up everything it can, and has finished processing, and all the outputs has been finished, and we can activate another cycle. And that's our idea, right? Okay. How do we do that? We need a bit of combinators here. So let's think about it. If we want this, if we want to know when the cycle ends and when the next cycle will start, we So we need to know when to start the cycle and when to end the cycle. And to determine that, we need another set of combinators to do the calculation for us. Okay, so now let's think about the default state. So the belt is empty and everything is empty and the machine is waiting for inputs here. So at this stage, this insert should be waiting for commands, so waiting for the materials to come to this range. And these buffer chests should be empty, so no raw materials are waiting for processing. And these buffers should be empty. No outputs are waiting to be removed. So the machine, so all the assembly line is completely clear. So at that stage, we want this inserter to activate and get a new signal. All right. So how do we determine that? Let's put the signals, put the combinators here. So first, we check the status of this buffer chest, and let's use the red wire to connect the buffer chest and inputs of it here. And if everything is 0, and then we output a green signal here. And the next condition is for the output buffer chest to be empty. So let's use green wire. So let's use red wire again to connect the output buffer chests. And again, everything is 0. We output 1 green signal. And the third condition is here for the sample. So when there is when the machine is waiting for an input, there shouldn't be any sample in this sampling area. So we use this. Connect this one here. So it is already on a red circuit. We can just use it, no problem. Connect this red circuit here, and we say if everything is 0, and then we put output 1 green signal. Okay. So if all the 3 conditions are met, and we're going to output 3 green signals to this insert. Okay, we set it to enable and disable, and the condition would be receiving 3 green signals. You see, this one is actually currently activated because we now has met all the conditions here. This one, the buffer chest is empty, so this one is green, and the sampling error is empty, so this one is green, and the output buffer chest is empty, so this one is green. So we have 3 green signals, and this one is activated. Now, the next step is how do we activate this? So now let's consider when one error has coming in and picked up, and then it's going to be put in here. If there's no signal, this one is immediately going to be like put back, put back into the main input belts. That's not what we want. We want this inverter to be disabled when the machine is processing. And only this one is only activated when the machine has finished processing. So how do we tell when the machine is processing and when the machine has finished processing? It's a little bit tricky because when this one first picked up, the input chest and the output chest are still empty, and there is one sample or here. And when the machine has finished the batch of processing, the input and output buffer chests are also empty, and there's still one sampling OR here. So the conditions are actually like pretty much the same. So this is where we use a little trick to use the timing to determine when to activate this one. So let's just say we want the end state. The end state. The machine has finished out processing. That will be empty input chest, empty output chest, and one sampling error or a sampling OR staying here. So this one will be empty, and this one will be empty, but here is not empty. It's not empty. So this is green, this is green, and this is not green, and this one will be 2. That will be 2. So now let's connect here, and let's set it to enable and green circuit 2. Okay, now we can see it's disabled. Yes, disabled. If I have a faster belt, I can just use faster belt on the main input and the slowest belt on the sampling area. So the idea is that when the sampling OR reach this tile here, and the main input has already reached this tile or here, and the filter inserter has already picked up and put in the buffer chest. So by the time this inserter wants to activate, and this buffer chest already filled, so this signal will be false, and this one doesn't match the activate condition. But now I only have the conveyor belt of the same speed, and I can still do that by just give this sampling a little detour, like this. Okay, and then I need to extend the reading area a little bit to cover everything here, and also we need this to be constant. We need the signal to be constant. Okay, so now this sample OR is going to get picked up here and travel all the way through here, and in the meantime these two inserters are going to be able to pick up a field to fill the buffer chest here. So once this is filled, and this inserter won't activate anymore. So alright, that's the setup, and now let's have a try. Now as I said before, we have two raw ingredients here. This one is rock and this one is like cracked rock. So let's say we got one batch. If it's not mixed, that just doesn't make any sense. So I want it to be mixed to show how the setup is going to filter the inputs for on its own. So this one is alright. It's ready. Now let's connect. Now see what it's going to pick up first. Okay, it's a cracker. You see, this one starts working, and the ingredient, the recipes are set, and the output is here, and this is the final output input. And output into this chest. In practice we can leave it wherever we want. You see, the filter inserters are only picking up this type of ingredients and not touching the rock. And now all the small ones are picked up, and we're waiting for this output chest to be emptied, and after that this inserter should be able to pick up another rock and initiate another cycle. You see that this one sample ore is put back, and another rock is picked up, and now we're working on the rock recipe. You see, this rock recipe is giving us a small cracked rock. Okay, I think that's enough for the demonstration. I think that's all. So now let's connect everything for 4 ingredients to be automatically processed. Let's see if it works. So this one got error out first. Just going to process error here. Oh yeah, there are 2 field error out, so it changes the recipe again. Error has finished. There's 2 field of them. Now it's going to change. Looks like there's some problem here. Yeah, but anyway, we managed to cycle to the next recipe, rock. And this one's still waiting for this buffer chest to be cleared. Okay, it's cleared. And see what's coming next. This one's still doing the rock. And this one's picking up the small rocks. Okay, looks like it's working fine. So this buffer chest here is coming with the crafting combinator mod, and is used for storage of any inputs or outputs still stuck in the machine when you change the recipe. So when the signal changes, it's probably still in half a cycle, and any material there will be put into this active provider chest here, so your logistic block can pick them up. Okay, now as we can see, there are only like so now the last batch will be the crystals here. Now we only got 1 each. The one of the sample ore here. So 1 arrow here, 2, maybe 2, because we've got 2 sets of machines. They pick up 1 sample ore each. So we got this like all thing or raw ores staying on the rack. Okay. So I can't think of any real application in vanilla game, because basically Factorio is about 1 machine doing 1 task, and which is part of the bigger picture. But this one, well, is it practical or efficient? I'm not sure, but it's kind of interesting because it's new, and it's also kind of realistic. It's like you have the bread machine, and if it detects flour, it can make bread. If it detects flour and butter, it can make you a cake, maybe. Okay. Alright, that's all. And thank you for watching.